I looked everywhere for a tool that could backtest trading strategies against specific prop firm rules and then run Monte Carlos with that data. All I wanted answered was a simple question. What happens if I run this strategy for an evaluation stage and this strategy for a funded stage on this prop firm account over this timeline? How much money would I have made? But that tool didn't exist, so I built it myself. Let me quickly show you how it works, and then I'm going to show you how you can build it for yourself. So right now, I'm in TradingView. I'm looking at a 15-minute chart of ES, S&P 500 futures contracts. So the first step to be able to analyze a backtest would be to do the backtest. Since we're simulating how a strategy would perform in a prop firm, we're actually going to have two different backtests. One for the evaluation stage, using the evaluation strategy, and one for the funded stage, using the funded strategy. But they're both going to be on the same asset and on the same time frame. So let's start with the first backtest, the evaluation stage strategy. We're going to come over to this tree-looking thing, and that's PineScript. This is how you code a strategy algorithmically in TradingView. And like I said, first, we're going to do the evaluation stage strategy. So we go up here, click on the evaluation strategy, and then add it to the chart. If you don't already have a strategy in PineScript, you can either translate it into PineScript from another language, you can write it from scratch, or you can use one of the pre-written trading strategies that TradingView offers. So once we've added the strategy to the chart, we're going to select which date range we want. For this backtest, we'll go from 2023-08-31 to 2026-07-23, and then select, and we're going to see the report updated for those dates. We can see some useful metrics here, but none of this is really applicable when we're thinking about prop firms. So we're going to click this table button and go over to the trading log, which you can see all the trades that this strategy took over this time period. As we can see, 1,434 trades were taken. Getting this panel out of the way, we're going to need to download this log as a CSV file. So we just click download and then downloads to your computer. Now we're going to do the same thing, but for the funded strategy for the funded stage of a prop firm. So first, I'm going to remove this strategy from the chart. For me personally, for a funded stage, I would trade on MES on the 30-minute time frame, and then we're just going to do the same thing. We're going to go over to PineScript. We are now going to select our funded strategy, and then going to add that to the chart. And then the key here is just make sure that we're using the same date range. So that was 2023-08-31 to 2026-07-23. And this is crucial because during the simulation, we'll be switching from one strategy to the other, and we need to make sure that one picks up where the other left off. And we're going to do the same thing, go over to the trading log, we can look at all the trades. This one took 2,000 trades over the 3-year period. I'm going to collapse this, get it out of the way, and download that CSV file. So that's all we needed from TradingView, just the raw backtesting data. If you were just going to deploy these strategies live, this would be very helpful. But in our use case, if we want to simulate against prop firm rules, we've hit TradingView's limitations. There's nothing more that we can do inside of TradingView. So I'm going to close out of TradingView and then go over and open VS Code. VS Code is Microsoft's coding environment, just a landscape where we can build a model. So first thing we got to do is we got to put the data into this model. Right now, if we look at the data folder, there's nothing in it. So this project is actually hosted locally on my computer. It's downloaded on there. And so I'm going to move both of the trading logs into the raw data folder. Then I have to rename them so that the code actually recognizes them. So this one's going to be eval_trades.csv, and this one is going to be funded_trades.csv. Now we've loaded the backtest into our model. If we close the downloads folder and we look at the raw data, we can now see that the trade logs are in our model. It's just a bunch of raw data. So now we run the scripts to make it useful to us. So I just put the scripts in a little note on my computer so that it's easily accessible. And so this first one that we're going to paste in, what this does is it runs the historical simulation over the exact data that we're giving it. So we click enter, it runs, and it populates over here with the results. We can see the equity curve. Now this is just numbers, we haven't done the visuals yet. The events file of every little thing that happened, trade, violation, reset, pass, summary of the different runs, what happened on each run, did we get a payout, did we blow the account, and then a summary of the different information. So over the past 3 years, if we were to trade those strategies, the evaluation strategy on an evaluation stage and the funded strategy on a funded stage, on a given prop firm account, I chose the rules of a top step 50K funded account for this. This is the results we would have had. We would have had about $200,000 in revenue, $27,000 in expenses, $210,000 in net profit. For some reason, I could not find a tool out there on the internet that already did this, and that's why I built it. But one backtest is just one possible path. Maybe those past 3 years were really lucky. What would happen if price action moved a little differently? And that's what we have the Monte Carlo simulations in this model for. So if we pull back up the scripts and we copy and paste this one, and then go ahead and run it, it takes a second, but what it's going to do is it's going to run 2 different Monte Carlo simulations. As we can see, the results are populating in now. Results_MC for Monte Carlo. It also prints some of the summary results in the terminal. So the 2 types of Monte Carlo simulations it ran. One, where the trades were sampled with replacement, and we can see the results here of each run of the simulation. So what this Monte Carlo is doing is it's resampling all the trades in a different order, and it's resampling with replacement. So one trade can be picked multiple times. It's then doing that, in this example, 10 times, but we could change it to make it do it 1,000 times. And then this type of Monte Carlo simulation is just shuffling around the exact trades that happened. So trade 1,624, for example, will only show up once, but it may show up in a different order. Now, normally, that wouldn't change your ending equity because it's the exact same trades. But with prop firms, it does. The order of the trade matters. If you have 4 trades and the first 3 are profitable and get you a payout, and then the 4th you blow the account, you still got the payout. But if, say, that losing trade came on the second trade, you would blow the account before you got a payout. So again, this is another example of these tools exist and they're out there on the internet for just live trading strategies. But when you start implementing these prop firm rules, there's just not many tools that can do this that are out there. And then just like for the actual historical simulation over the real historical timeline, we have summary runs over the shuffled timelines as well, and event logs, and what will be equity curves. And so when I say what will be equity curves, what do I mean by that? Well, this is a lot of numbers, and it doesn't really mean anything to me right now. It's just a huge log, so we need some way to visualize that. Well, if we pull up the last script, that's exactly what that does. It generates the visuals. So we'll go ahead, copy and paste that into the terminal, let it run, and boom, the visuals were generated. I'm gonna make this full screen. So it's a little compressed right now because I had to make it full screen, but as we can see, we have the equity curve for the historical simulation, which gives us so much more insight because we saw that huge profit, but that didn't come until halfway through, until 1.5 years into the simulation. It was just losing money until then. Then we can look at the 2 different types of Monte Carlo simulations. We can see, well, we actually got lucky. Over 200,000 net profit. That was really good. If we were to shuffle around those trades, on average, we'd be looking more at 150,000 net profit. And sometimes it might even be negative over those 3 years. So if this model looks like something that would be useful for you, keep watching and I'm going to show you how to build it. So why did I start with that walkthrough? Well, basically to answer the question of why would you listen to me? I'm not an expert, but I just showed you what I built, I showed you how it worked, and I showed you what the results were. If that's something that looks like it'd be useful to you, then keep watching, and by the end of this video, you'll know how to build one for yourself. Alright, so how are we actually going to do this? Well, we got to start with the architecture. How is this thing going to be set up? As you saw, there's 3 different sections and 20 different files, and they all reference each other. For me, at the beginning, it was a little overwhelming, but if you get the foundation right, it's actually super smooth. Next, we got to build out the rules engine. This is what really separates this backtesting model from all the other ones out there. You're testing against the rules of a specific prop firm account that you want to trade. So we got to make sure the model understands those rules. Next is the simulator. So this just looks at all the trades and applies those rules over the timeline with the actual trades that we gave it. And that gives us the historical data of one historical timeline that we may have got lucky on. So to test across a bunch of different historical timelines without using up all your out-of-sample data, we add the different types of Monte Carlos, shuffling the trades around, resampling, seeing what could have happened. How long of a dry spell might you be in? How bad could it get? How good could it get? Did you get lucky over that 3-year simulation? or were you about average? So these two things are going to give us a lot of data. So then we got to move on to visualization so that we can clearly see, understand, and digest that data. At the walkthrough at the beginning, we saw even though we had a huge net profit over that historical backtest, it almost all came in the last year and a half. The first year and a half, it was just losing money. Then lastly, we're going to briefly do some takeaways of why this might be useful and how it could affect you. Now, a little heads up. I'm not going to go over specifically how to write the code for each piece of this model. If you know how to write code, great. If not, also fine, have an LLM do it for you. What this video is doing is filling the gap between every trader has access to free LLMs that can write code. Not every trader has this model. So how do we bridge that gap? That's what we're going to get into. So the basic architectural overview is that we load in the trade logs as CSV files from TradingView, and then we send them over to the data loader. And we do that to break the different trades into trade objects that the model can understand and really easily interpret. Then we write the rules of the given prop firm account that we want to use. In my case, it was the TopStat 50K funded account. And then we move over to writing the simulator that applies those rules to our trades over the timeline. Just this first 1, 2, 3, 4 sections is very valuable in and of itself, but we really elevate it when adding this fifth step of the Monte Carlos. We can get a much better idea of how good a given strategy actually is and know if we just got lucky or if it's actually that good. Then elevating another step, adding the plots, the visuals to easily understand and digest that information. So just as an example, here's what my file setup looked like, the folder setup. This section is the actual simulator itself. This is what calls the tests and runs them. And then this is where the data is stored, the CSV files, and then where the different results are stored. So like I mentioned, these rules specifically are for a TopStat 50K funded account, but it's in no way hard coded to that account. You can just tweak the numbers to make it any prop firm account. But if you're curious what those rules are, here's what they are in TopStep's language. So moving on to the simulator. So the simulator is really just a loop, walking through your trades one at a time in order, asking one question. Did anything change? So you start, obviously, at the eval stage. Then a trade happens. It asks, did you fail? Did you pass? Another trade happens. It asks, did you fail? Did you pass? Until one of those two things actually happens. And so if you pass, then you move on to the funded section. And the same thing happens. It just loops and it asks, does anything happen? A trade happens. Did you blow the account or did you get a payout? Did you blow the account or did you get a payout? So let's say enough trade happens and you end up blowing the account. Then it resets, it charges the $85 fee in this case, and you go back to the eval stage. Then go again. Trades in eval stage. Did anything happen? Okay, you failed. Well, charge the reset fee, $85, go back. And it just loops this over and over and over again, trade by trade. Now running through this once on the historical order is useful, but it's just one path through your trades. That's where Monte Carlo comes in. And this is where I actually want to slow down. Well, your historical trade sequence is one specific order that those wins and losses happen to fall in. If a big losing streak had happened at the start and not the middle, would you have survived the evaluation stage? Monte Carlo answers that by generating alternate, statistically valid orderings. So first let's look at method 1, resampling with replacement. So how this Monte Carlo works is picture a big bucket of all your trades. The historical order is 1, 2, 3, 4. And say, this was profit, this was profit, this was profit, this was loss. And you were in the funded stage, and you ended up getting your payout because these 3 profitable trades got you the payout. Well, what a Monte Carlo with resampling does is it throws all these trades into a bucket. So you got 1, you got 2, you got 4, you got 3, and it shuffles them up. And then for however many number of trades there is, it picks one out of the bucket, randomly. So let's say the first one it takes out is 2. And what with resampling means is you actually leave that 2 still in the bucket. You note down that it was a 2 and you essentially put it back in. And then it picks another random one. And so it could pick 2 again. Then it picks another random one. And maybe it picks 4. And then another random one. And it picks 4. And so now it's gone through the number of the list. N equals 4. It picked 4 random numbers with replacement. And so in this new alternate, statistically valid order, you would have had profit, profit, loss, loss. And these 2 wouldn't have quite got you your payout yet, and then this would have blown the account. And these are all real trades on real data, just in a different order. And then the cool thing about Monte Carlo simulations is you can do this as many times as you want, right? You can do another one of this is, say, the first simulation, and then you do a second simulation, and it's 3, 2, 1, 1. And you can just keep doing them. And you can see all the different possible combinations of different things that maybe could realistically happen. And so this one, shuffling without replacement, is actually much simpler. It's the same thing, you got your bucket, except once you take a number out of the bucket, it doesn't go back in. So you can only pick each trade once. And then what I want to show here is how truly simple this can be. But there's really one line that does most of the work. So all it's doing is it's looking at the list of trades, and then it's looking at the length of that list and making that a number, a constant. And I think the second list was about 2,600 something trades long. So this would become 2,600 and say 14. So it's going to make a random choice from the list of trades 2,614 times, picking a random one until there's no more left to pick. And that's really all this type of Monte Carlo simulation is doing, but it can still be super helpful, as we'll see later when we look at the results visualized. So like I mentioned earlier, we can run as many simulations as we want. Obviously, if you run an absurd amount, it might take a lot of compute, but it's just a simple for loop. You can make this I whatever you want. We just did 50, I think, but it's just going to keep iterating through this in a circle. And so you can just get a large amount of data really quickly. So with the charts, the main goal is speed. As they say, a picture is worth 1,000 words. We can just look at the chart and see exactly what happened. If we were to scroll through those events log, personally, I would never get through it. So yeah, as we see on the top here, we have the one real historical run. Then the middle is 50 resampled paths. And then the bottom is 50 just shuffled paths. So how are they actually built? Well, we look at those events logs, going row by row, whether it's a reset or a payout, because those are what actually affect the net profit. So if it's a reset, then there's a fee of $85. So cumulative profit minus $85. Else, there is a payout. This is 0 here, but that's because the payout amount is not fixed, like the reset fee. So whatever that given payout is, you add it to the cumulative profit. And that is how we generate these curves. It's again just another for loop going row by row, checking what happens. If it changes the net profit, it either subtracts the fee or adds the payout amount. And then something worth noting is, I think I've referred to them as equity curves. They're not actually account equity curves. We're going through hundreds of accounts in this simulation. It's a net profit curve, and then it's also not curved. It has jump changes. There's no change over time to how much money you're making until either a reset or a payout, and then it jumps. All right, so what does this actually mean? Well, the spread between the lines is essentially the risk. If most lines are clustered together and profitable, that's a robust strategy regardless of trade order. If the lines fan out wildly, and some are deeply negative and unprofitable, you may have just got lucky with that one historical simulation. The actual value of a Monte Carlo is one backtest can look great on a lucky roll. A Monte Carlo tells you how much of your result is skill and edge versus just the order the winds happen to fall in. Now, this model isn't going to guarantee any results, but it should give you a better idea of if your strategy is going to survive a prop firm. And personally, that's been very helpful to me, and I imagine it would be very helpful to you as well. That's why you clicked on the video. So my plan is to make this not just hosted locally on my computer, but make it an application where anybody can throw in their trade logs. They can choose a different type of prop firm account, and they can run the simulation for themselves and get their own results. So that's the goal. Subscribe if you want to see that. And as always, take everything I say with a grain of salt, as I am not an expert, and I'm sharing this with you because I just learned it myself and I found it really valuable. Thank you for watching, and let me know anything you want to see next.